Hello, my name is Daniel Choi. I'm a master's student studying wildlife biology at North Carolina State University. I spent this summer working at Padre Island National Seashore on the Texas coast, where I examined the threat of marine debris on sea turtles. Marine debris is considered one of the greatest threats to marine wildlife, and you've probably seen images like those on the left. The turtles that are incredibly entangled in nets or that have large straws stuck in their nostrils. But what about the turtle on the right? While it seems healthy on the surface, we really don't know what's going on underneath its shell. Answering that question is the overall purpose of this project, trying to examine what's actually being consumed by sea turtles. In the past 3 decades, marine debris has increased exponentially worldwide. Yet debris in consumption by green sea turtles in the Gulf of Mexico has not been well studied since the 1990s. And further, existing studies are inconsistent and hard to interpret. To conserve this endangered species, it's very important to establish a robust understanding of marine debris consumption. So how do you actually measure debris consumption? As it turns out, the process is very simple, just painstakingly tedious. The basic methodology consists of opening a turtle's GI tract and carefully finding every piece of debris. Then you dry all items, classify them by type and color, and then record mass, length, width, and depth. Over many years, deceased stranded turtles in Texas were necropsied and their GI tracts were examined. This summer, I examined 300 frozen GI tracts. With the help of technicians, I measured debris items from those and 200 more that had already been dried. We also looked at 400 loggerhead and Kemp's Ridley sea turtles that had already been preserved, and that data will be analyzed later. In total, my sample included 507 green sea turtles from 1987 to 2019, and nearly all were juveniles. Based off recent research suggesting juvenile diet differs by size, I divided all turtles up into 4 size classes. These size classes are important as they indicate habitat and foraging shifts by juvenile turtles that are unique along the Texas coast. So, what did we learn? First, the average amount of debris ingested per turtle was 0.25 grams. Second, across all turtles, 51% contained debris, and this number increased from 40% to 70%. Now, in other regions, the average mass per turtle was 1 gram, 10 grams, or even 40 grams. So here it was exceptionally low. Next, we find more insightful patterns when we relate debris to turtle characteristics. First, the small size class was more than twice as likely to consume debris. Second, debris was primarily hard plastic fragments, plastic sheets, and fishing line, which likely reflect environmental availability and not special selectivity by turtles. Small turtles mainly ingested hard fragments, while larger turtles were more likely to ingest fishing line or plastic sheets. This size-based difference in both debris type and consumption likelihood suggests that juvenile green turtles in the Gulf variably consume marine debris according to the habitat where they are foraging. For example, this is sargassum algae. When Texas sea turtles hatch, they swim to these nutritious floating mats where they spend the first period of their lives. Diet studies have linked higher debris consumption to foraging on this algae, the hypothesis being that this floating mat catches buoyant fragments in the Gulf, which are then accidentally consumed by small turtles, as opposed to being purposely ingested. When larger, these juvenile turtles move inshore to bays, channels, and lagoons, where they eat larger amounts of seagrass instead of sargassum algae. As opposed to smaller turtles, the larger juveniles consume more plastic sheets and fishing line, which may be more common in these near-shore environments. It seems that overall, juvenile green turtles in the Gulf tend to consume debris only incidentally, whereas studies elsewhere have reported adult turtles specifically pursuing plastic bags in the same manner as a jellyfish. Instead, generally debris items in our study were very small, and this may be why we did not find any sign of death-related debris consumption, such as gut impaction or perforation. Indirect mortality, such as reduced fitness, however, is not easily measured. This is not new and remains a priority question worldwide. Research has tried to quantify risk based on total mass or number of items consumed. However, this is really difficult because many metrics are needed. For example, at the same mass, plastic bags have far greater surface area than rubber and likely increase risk in different ways. And this is not the only research avenue remaining. A few others include the need to compare species in the Gulf and to study specifically adults of all species in the Gulf. And finally, worldwide, it is very important to have studies like this that have very large sample sizes and that are standardized so that more trends can be accurately compared across regions. In conclusion, I hope you take away 2 key points. First, debris consumption by green turtles in the Gulf of Mexico increased from 40 to 70% between the 1990s and 2019, but it is still low at just 0.25 grams per turtle. And second, This project represents the largest, most in-depth study of debris consumption by any sea turtle species to date. With that, thank you. I'd be happy to take any questions.